Hello dear students. In this video, we will learn how to display a queue. In this queue drawn on the right hand side of the screen, we have three nodes storing 10, 20, 30. 10 being the front, so front pointer is pointing to that 10 and rear pointer is pointing to the node which stores 30. Of course, if you are asked what is the data stored in this queue, your answer should be 10, 20, 30 in that sequence. It should not be 30, 20, 10 because queue is always maintained read from front to rear, first in, first out. So to display this queue, we have again passed the address of the queue and the pointer P points to the queue. Now the plan is like this. What we will do is we'll use a pointer A. Let's say A. Actually, I have used a pointer called newrec. Although I could have named this as a very small name instead of such 6-letter name. After all, variables can have any name. So A, B, C would have been okay. Anyway, but think of a pointer A and we will say A, you should point wherever the front is pointing. Note that front is pointing at node 10. So A points over here. And now using simple printf, I'm writing in short print A arrow data. If I write this, I'm not writing C like statement. I'm writing just in short. If you say print A arrow data, then A arrow data, as you see, A arrow knock here, data is 10. So this first value will get printed. And after this line, if you advance A by writing A is equal to A arrow next, what that means is A should change. A should no more point to 10, but A should point wherever its next is pointing. And observe that its next is pointing to the node which stores 20. So this updation, just check out, this updation means that A will no more point at 10, but A will point to the node which stores 20. And now if you are able to repeat this, after changing A, you again ask print A arrow data. So what is A arrow data? Just check out. A arrow will take you to this node and data there is 20. And after printing A arrow data, you again ask A to become A arrow next. But then A arrow next here means 20 is next, isn't it? Which is 30. So this pointer A will no more point to 20. But now this A will point to the 20's next, which is pointing at 30. And what if we again repeat this? Printf. Then it will print 30 because A arrow data now is 30. And after that we execute A is equal to A arrow next. But observe A arrow next means 30 is next, which is null. A is becoming A arrow next, isn't it? But 30 is next is null. That means A will literally become null. I hope you have again understood this. We have seen such display function number of times in simple linked list programs in stack using linked list. So what should we do when A becomes null? Note that A was pointing at 10 to start with, then A was pointing at 20, then A was pointing at 30, but now A is not pointing anywhere. A has become null. So when A becomes null, we must stop. So you just check this code now. I'll just remove a few things here. Okay, I hope this is readable. We have declared a newrec pointer. This is like a temporary pointer. Then newrec should point wherever front points, P arrow front points. So newrec points at 10. Now just ignore this while loop for some time, but just see the body of the while loop. We are printing newrec arrow data, which is 10, and newrec moves to the next node. So basically newrec now points at 20. And now if we repeat the while loop, this is going to print newrec arrow data, which is 20, and newrec points to next node. So newrec points at 30. And again you repeat the while where we are printing 30 and newrec now is equal to newrec arrow next, but note 30 is next is now null. So what that means is newrec is literally going to become null. Newrec will become null. And if new rec becomes null, you should stop because now it's not pointing to any valid node. Hence, the condition written in the while loop is that you must print the data and you must advance new rec to the new node only if new rec is not equal to null. So as long as new rec is not equal to null, continue. But as soon as new rec becomes null, this while loop will terminate and that ends the display function. After display function, I have written destroy, but just as in the previous videos I said, this is not important. I just written it. Destroy actually what it does, delete function will delete only one node at a time. Just in the previous video, we saw how to delete one node. But destroy will instantaneously delete all the nodes and make the queue empty. That's very dangerous operation actually, isn't it? But you just go through this taking interest. I'm not discussing destroy function. So these are the 5 cases actually in main, where first case was insert, second was delete, where we checked whether it is underflow. First of all, if it is underflow, we don't delete. Whereas if everything is okay, if the queue is not empty, only then we delete. Case 3 is display. Case 4 is destroy. Case 5 is exit simply. I have declared all the functions on the top here because the functions have been defined below main. So you know if the functions are defined below the call or below main, then you must declare them. Declare them above main. So that's it. That is the implementation of the queue. Now, before I end this discussion, such a queue is known as linear queue. This is a linear queue. Why it is known as linear queue? Instead of telling why it is linear queue, it is better I will tell you why it is circular queue. What is circular queue? I will tell you. Instantly know what I am talking about. Correct? You don't need a teacher to tell you what is circular queue. Note, 10 is followed by 20, 20 is followed by 30, and if 30 is next, instead of making it null, if this pointer next is asked to point to 10, then this is still a queue because 10 is still the frontmost. This person was in the queue first and 30 was late, 30 came last. So still front and rear are pointing to 10 and 30, but 30's next is pointing back to 10. That is frontmost. Then this is circular queue. By the way, this circular queue implementation we are going to learn in the next videos. But then the kind of implementation that we did just now is the linear queue. Now, reason out again why it is linear. Tell me, if you delete some node here, who will get deleted? Obviously 10, correct? Because it is frontmost. But then what happens to front? Front goes to the second node linearly, isn't it? Look at the increment. Look how front advances by one node, isn't it? And what if we want to insert a new node? Say 40 we want to insert, correct? Which has next, of course. Then this next of 30 will no more be null, but it should point to 40, and 40's next should be null, isn't it? But what happens to rear? Rear points to 40 now because this is the last node. So are you seeing how rear also advances linearly, one by one, one after the other? So hence it is called as linear queue. Isn't it so? Whereas if it was circular queue, then 40 is next, which is the last node, won't be null, but this will point back to the first node where the front is pointing. 20 is the first node now. So see you in the next videos where we will see some more types of queues like circular queue, and some applications also we will learn on stacks and queues. Thank you very much.